So this is the second video out of 4 on the precise definition of a limit. And in the first video, I focused on two-sided limits. And in this video, I'm going to focus on one-sided limits. Before I get to the one-sided limits, though, let's recall some of the information we talked about with two-sided limits. So the definition looks like this. Let f of x, our function, be defined on an open interval around n, which is our input value, our x's. We say that the limit of f of x as x approaches n is the number L, our guess for the y value, and we write it like this. This is our notation. If, for every epsilon, remember epsilon is a small positive distance greater than 0, there exists a corresponding number, delta, also a small positive distance, such that if my x values are close to n, between 0 and delta, this implies that my f of x values should be close to L within epsilon, okay? So we want x values close to n, and we want f of x values, y values, to be close to epsilon. I'm going to go ahead and show you real quickly again what this looks like. So f of x is this blue curve. It's my function. Okay, we're going to use L plus epsilon and L minus epsilon as boundaries. That's why we have this blue shaded region. This is what we want. We want everything in this boundary so it's close to L, our y value that we think is the correct answer. Now, this green region shows what x values we're going to test. We're going to test x values between n minus delta and n plus delta. And we want every x value in this green region that we plug in to produce y values in the blue boundary, okay? So we want all of these x's in here to be between these two dotted lines that are horizontal, okay? Now notice we're checking on both sides. So we're doing n minus delta and n plus delta. That's what makes it a two-sided limit. Now, I'm going to mention that there's an alternative way to write the definition. So instead of saying x minus n is greater than 0 but less than delta, we could actually write our x values as being between n minus delta and n plus delta. This is not as common. This first way it's written is the more common mathematical way. Similarly, we could write f of x minus L is less than epsilon as L minus epsilon is less than f of x is less than L plus epsilon. Again, the first way is much more commonly written, but it is also true to say the second statement as well. Again, this is except where x equals n. It may not happen there. Remember, we don't have to be defined. We might have a hole or an asymptote or something at x equals n. Now, the question arises, how does this definition change for one-sided limits? Well, if I'm going to do a one-sided limit, I really only have to check one side. So the left-hand limit is going to, again, notice this is how we're going to write it, is we're going to use that little minus sign to represent the left side. And notice all I did was I removed my absolute values from the first part of the statement. And I wrote n minus x, because in this case, I'm going to choose smaller x values than n. So we should get a positive answer here. Now, all I've done is I've changed this first part of the definition. Now, again, there is an alternative way to write it. So if you don't feel like writing this statement right here, you could write it as n minus delta is less than x is less than n, or you could write it that negative delta is less than x minus n less than 0. All three of these statements are equivalent, so any of these three options for the first part work. But notice the second part of the definition has not changed. I'm still approaching L, so this still is the same answer on the end. Okay, I'll show you how this looks visually, okay? So I made a piecewise function here. Again, the blue curve is the piecewise function. I still used L plus epsilon, and L minus epsilon is my blue boundary. And what I'm doing is I'm just checking these numbers over here left of n, so n minus delta. So I only have to check half of the region. I'm checking the side that's less than n. And I still, again, want this entire region to be inside this blue boundary, okay? Notice it ends right there at this curve, and so it's all within the boundary. So if I want to do the right side, I again put the little plus sign here in the corner so that I recognize I'm doing the right. And instead of writing n minus x here, I'll write x minus n. Notice no absolute values again. Again, there are other ways you could write this. You could write it as 0 is less than x minus n is less than delta. or you could write it as n is less than x is less than n plus delta. These two statements are still equivalent. Again, the end part of the statement hasn't changed. I'm still approaching L at the end, so this part still stays the same. Now, again, using the same function, all I did was I went from n to n plus delta instead of n minus delta. Gave me this region here. Now notice this one's a nice big region. We have lots of room to work with. We're still going to be between L plus epsilon and L minus epsilon, and I want this section of the curve, this section of my function, to be in between the blue boundaries, which it is. So, to kind of recap all this information, all one-sided limit definitions start the same way. There's more than one way to write it correctly. We have options. Just focus. The left side has one option. The right side has other options. Okay? Remember that x equals n. The dot is not the important part. The important part is the curve. So again, going back, it doesn't matter whether we have an open dot or a closed dot. That's not the important part. The important part is where the curve is. So hopefully this helps you better understand what this definition will look like for one-sided limits. I look forward to seeing you in the next video.